Hello, learners. It is good to see you again. In our last video, we studied about the translator, its need and types. In this video, we'll study about compiler and the compilation process in detail. A question arises. How does a compiler compile the code? Well, code compilation involves multiple phases. During compilation process, output of one phase is passed as an input to the next phase. These phases are divided into two major parts: analysis and synthesis. Analysis part divides the input source program into constituent pieces and imposes a grammatical structure on them, which further uses the structure to create an intermediate representation of the source program. It is also known as front end of compiler. Information about the source program is in data structure called a symbol table. Synthesis part is the back end of compiler. It takes the intermediate representation as input and transforms it into the target program. Now, let's discuss these phases in detail. Compilation process divides into following different phases: lexical analysis or scanning, syntax analysis or parsing, semantic analysis, intermediate code generation, code optimization, code generation. First, let's talk about lexical analysis. In the first phase of compiler, source program having stream of tokens is scanned and characters are grouped to form lexemes, which produces token as output. Let's take an example. C is equal to A plus B into 5. Here, compiler generates lexemes which are C is equal to A, B into and 5, where C equals to A, B multiplied by 5 and match it with specific pattern to generate tokens. Next is syntax analysis. Syntax analysis phase covers the parsing. Syntax analyzer analyzes the token streams against the grammatical rules of a language and detects errors, if any, in the code. Its output is in the form of a parsee tree. A parsee tree describes the syntactic structure of the input. For previous given example, the parser tree will become like this. Semantics analysis. Semantics analyzer performs the following functions. That is, find out following semantic errors. For example, look at that code here. Int a is equal to hello. A string is given under variable that has the data type integer. So, these are not compatible, which means the integer type available cannot store a string because they are not compatible. In simple terms, integer variable stores integer value and character variable will store string values only. Hence, this phase checks these types of errors. Type mismatch error, variable left undeclared. Misuse of reserved identifier, declaring a variable multiple times in a scope, variable assessed out of its scope, mismatch in actual and formal parameters. Generation of intermediate code. In this phase, syntax tree is converted into intermediate code form. One of the most famous intermediate code form is three-address code, in which each statement can have at most 3 operands and 1 operator. Let's take syntax tree that was generated in last phase. Its three-address code will be T1 is equal to 5, T2 is equal to B into T1, T3 is equal to A plus T2, T4 is equal to T3, C is equal to T4. Here, T1 to T4 are temporary variables. Code optimization is the next phase. It takes the intermediate code and outputs the optimized intermediate code that is efficient. Optimized code results in faster executable machine code, however, it does not affect the result. Some of the optimization steps are removal of unreachable code, calculation of constants in expressions and terms, collapsing of repeated expression into temporary string, loop unrolling, moving code outside the loop, removal of unwanted temporary variables. In the intermediate code that is generated in previous phase, we can remove T4 as it is unnecessary. So the code will become T3 is equal to A plus T2. C is equal to T3, where T3 is equal to A plus T2. C equals T3. Last phase is code generation. It gets intermediate code and produces the target object code. Also, intermediate instructions are translated into a sequence of machine instructions that perform the same task. However, this code must be optimal in terms of memory and CPU usage. So, these were different phases of compilation process. By using them, a high-level language is translated into machine-level language. Thank you.